Yeah, hello everyone. So in this problem, the length of AB is 3 and BC is 4. So that means using Pythagorean theorem, AC is 5 and D divides the segment AB with a ratio of 2 to 1. Because the length of AB is 3, that means the length of AD is 2. So let's make the position of A at the origin. So A is at the origin and B's coordinates are 3 and 0 and C's coordinates are 3 and 4. And the length of a segment CG is 2 times the square root of 6, and we want to find the coordinates of G. So let's say the coordinates of G is A and B, and because G is on the small circle, the A and B satisfy the equation this A squared plus B squared is equal to 4, and because the length of CG is 2 times the square root of 6, we can make this second equation, the distance between the 2 points G and C is the square is 24. So if we solve this system of equations, when you open the squared form, we get this equation. So that means B is equal to 5 minus 6A over 8. And then we are going to put this back to this original B. So A squared plus this B squared is equal to 4. And then multiply 64 to remove the denominator. And then using quadratic formula, we get the coordinate, the value of A. Because in this diagram, the G is located to the left side of the origin. So that means G's x-coordinate should be negative. So that's why I'm only taking this negative sign in the quadratic formula. So the value of A is 3 minus 4 times square root of 15 over 10. And then because B is this 5 minus 6A over 8, so I'm putting the value of A. And if we simplify this expression, we can also get the value of B. And for the coordinates of point E, because this angle, angle the CAB, if we put this vertical segment, the ratio is still 3, 4, and 5. And because the length of AE is 5, let's say this point is H. the length of AH, which is x coordinate, is 2 times 3/5, which is 6/5. And the length of EH, is y coordinate, is 2 times 4/5, so that makes 8/5. So now we have coordinates of G and E. So we can find the length of EG. We can subtract these two x and y coordinates and make the square. And if we open this square, the length of GE is the square root of 6. So in triangle CGE, the length of C is 3, because we subtract 2 from 5. So now we know all the side length of triangle CGE. And if we know the 3 side length, we can find the cosine value of this theta. So cosine theta is, using the side length, we can find this value. And because this quadrilateral is inside the big circle, the opposite angle is the pi minus theta. Because cosine pi minus theta is equal to minus cosine theta, the cosine pi minus theta is square root of 3 over 2 times square root of 2. That means sine pi minus theta should be square root of 5 over 2 times square root of 2. And finally, we are going to use the law of sines in triangle CGH. We want to find the length of GH. So let's say the length is x. And because these two angles have the same measure, we already know the angle HCG, the sine value is 5/5, because that's equal to the sine value of BAC. So using law of sine, this is 2 times the square root of 6 over the sine pi minus theta. This one is equal to x over this sine value of HCG, which is 4/5. So make the cross product. So the sine pi minus theta value is square root of 5 over 2 times square root of 2. So times x is equal to the product of this, the 8 square root of 6 over 5. So the value of x is, when we divide the 8 times square root of 6 over 5 by the square root of 5 over 2 times square root of 2, we get this value. And then simplify this. Square root of 12 is 2 times square root of 3. And then multiply square root of 5 to the numerator and denominator. So that's the final value of x we can find. So the answer is option 4.